Okay, now that we have an idea of what multiplicity is, let's put all this together and sketch the graph in example 1, g of x. So the first thing I'm going to do is I'm going to write g of x out without the exponent so that we can see what this looks like expanded. So I have x plus 3 times x plus 3 because it's squared. X minus 1, 1, so I only have one factor of that. And then I have 3 factors of x minus 4. Okay, so now when we go to find the end behavior, we need to know the leading coefficient, if it's positive or negative, and we need to know what the degree is. If I were to actually count all these x's, I'm not going to actually multiply that all out. That would be really long and tedious. So I'm just going to try to envision, if I were to multiply this all out, I would have x times x times x times x times x times x. There's 6 x's there. So my degree would be x to the 6, or I should say 6 is my degree. And my leading coefficient would be positive. If I multiply that all out, I can see that there's no negatives in front of any of those x's. So I'm going to have a positive leading coefficient. So that means my end behavior, when I go to graph this, if I have a leading coefficient that's positive and a degree that's even, my arrows are going to be up in the first and the second quadrant. So I'm going to draw my arrows here to remind me that when I finish drawing my graph. Okay, so I have my arrows in the first and the second quadrant. If you don't remember that, you can go back and refer to the previous chart that we made in the last section. Okay, the next thing that we need to do is find the x and the y-intercepts. Well, to find the y-intercept, that's the value of y when x is 0. So I would put in 0 for all of these x's, and then I would find the value of y. So I would have 0 plus 3, which is 3, times 0 plus 3, which is 3. And I would go through and I would multiply that all out. So I would have 3 times negative 1 times negative 4 times negative 4 times negative 4. And when you multiply all of that out on your calculator, you're going to see that you have a y-intercept of 576, which means it's going to jump up there pretty far. Okay, now for x-intercepts and multiplicities, we'll do those together, since they go hand in hand. Okay, if I look at this, I have an x-intercept of negative 3, because if I plug in negative 3 for x's, that's going to give me 0 for y. So I have negative 3. Because I have a factor of x plus 3 twice, that's going to be a multiplicity of 2. I also have an x-intercept of 1, but that only has a factor x minus 1, 1. So this is going to be multiplicity 1. And then I have one other x-intercept. If I plug in 4 for x, that's going to give me 0 for y. So when I plug in 4, that's going to give me a multiplicity of 3, because I have 3 factors of x minus 4. So I'm going to go ahead and graph this. Now on the x-axis, we don't have any unusually big numbers for x, so I'm just going to go by 1s on my x-axis. So my scale for x will be 1. My scale for y, though, because our y-intercept is going to cross at 576, I'm going to make sure that I go by 100s on my y-axis. 1, 2, 3, 4, 5, 6. Okay. So my y scale is going to go by 100s. Now, let's plot our x-intercepts. I have an x-intercept at negative 3. I have an x-intercept at 1. And then I have an x-intercept at 4. So if you notice, the x-intercept at negative 3 has a multiplicity of 2. And if you scroll back up and look at the little chart I gave you, that means it's going to do a touch and turn. It's not going to actually cross over the x-axis. So it's going to come down. It's going to start with this arrow. It's going to come down, and it's going to bounce back up. Now, because I have a y-intercept at 576, let me put that on here, that would be somewhere in here, close to 600. It has to pass through that too, so it's going to bounce back up and touch that. Now the next point that it's going to hit is 1. And that has a multiplicity of 1, so that's going to just cross straight through. And then at 4, it has a multiplicity of 3, so that's when it does that little fancy swirl thing when it crosses through. So it's going to look like this. And then it's going to come back up and finish up here. Now, one thing I want to point out is that this is just a sketch to see what the shape of the graph looks like. So, for example, I don't know, unless I plot some points to double check, I don't know if the graph comes down like this or it comes down like this. I'm just making a sketch. If I want to know how far this dips down, I need to actually plug some numbers in between. Here's 1, here's 4. I need to plug in a couple numbers in between 1 and 4 to see how far that dips down if I want to be a little bit more accurate. But right now we're just drawing a sketch. And then you can plug it back in on your calculator. If you plug this in on your y equals on your calculator and you adjust your screen so that the y is on a scale of 100 and your x is on a scale of 1, you should see this picture exactly how you drew it, minus the fact that we're not sure how far down it dips over here, unless we plot some points in between. So always go back and double check it on your calculator. It doesn't hurt.